Hello. Uh, this is Dr. Omar Amin Mohammed from Bauchi State University, Gado. Today's video is the 10th video of Basics of Biostatistics. In today's video, we are going to talk about determining sample size. Now, a researcher needs to decide on the appropriate sample size to use at the planning stage of his experiment. Usually, the population is very large and you can't study everything, so you need to sample to represent the population based on our last video. Now, there are many ways to determine sample size, but we are going to look at the two most used ones, which are estimating the sample size based on a mean, estimating the sample size based on proportion. Now, estimating the sample size based on mean. Now, the sample size based on mean can be calculated using the formula n is equals to z square, population variance square, and d square, and where your z is the value from the standard normal distribution for a given confidence level. Example, 95% confidence, your z is going to be 1.96, while this represents the variance of the population, while this is maximum allowable absolute difference between the sample mean and the true population. That's the margin of error. If the variance of the population is not known, this occurs in most cases. It can be estimated from the results of previous similar study or from a pilot study whereby a sample may be collected from the population. And the variance calculated, which can be used to estimate the variance. Now, example. Suppose a researcher is worried about the increased level of obesity among children under the age of 12 and wants to conduct a survey to investigate that. What sample size will he need to be 95% confident that the sample mean is within 5 grams of the population mean? Assume that the previous survey of obesity among young children has shown the population standard deviation to be 20 grams. Also assume that the researcher would like an interval of about 10 grams wide. That is, the estimate will be within 5 grams of the population mean in either direction. This indicates that the margin of error is 5 grams. Now, this is the solution. We just put our formula. We use our z value, which is gotten from the z table, and then we substitute it, and you can see here we get 62. So this means that this researcher is going to use 62 as a sample size. Now, the next one is estimating sample size based on proportion. To calculate the sample size based on proportion, the sample required to be estimated, the researcher needs to be 95% confidence, and you can use the following formula, where NR is equal to Z square PQ divided by D square, where NR is the required sample size, where P is the proportion of the population having the characteristics, and Q is given by 1 minus P, and D is equal to the degree of precision. Now, the proportion of the population P may be known from a prior research or other sources. If it is unknown, use P is equal to 0.5, which assumes maximum heterogeneity, that is 50-50 split. The degree of precision is the margin of error that is acceptable. Setting D is equal to 0.02, for example, will give you a margin of error of plus or minus 2%. Now, let's look at an example. You are investigating the use of traditional medicine for curing ailments and want to estimate what proportion of the population treats ailments this way at an approximate 95% confidence level. Since new data are available on the proportion currently using traditional medicine, you take the worst case scenario and set P is equal to 0.5, and therefore Q is equal to 1 minus 0.5, which gives you 0.5. As this is a preliminary study, you are prepared to accept a margin of error of plus or minus 5. So you set D is equal to 0.05. To determine the minimum sample size, you then apply the formula. After applying your formula, your results you approximated to 384. Cheers. See you soon.